When you are viewing a graph in the standard viewing window, recall that the x-axis goes from -10 to 10 with increments of 1. And the y-axis goes from -10 to 10 with increments of 1. What if you could only see part of the graph in the standard viewing window? Well, there is a way to customize the viewing window so you can see a better view of the graph. This will be illustrated in the next two examples. So let's take a look at example number 1. Let's say that we want to graph y equals -x plus 15. So let's go ahead and input that. Press y equals -x plus 15. Now, you know that this is a linear function, so it's going to be the graph of a straight line. Alright? If we go ahead and hit graph, there it is. We can see part of that straight line. Alright, now usually when you're graphing a straight line, there are 2 points of interest, and that is the x-intercept and the y-intercept. So remember that the x-intercept is where the function hits the x-axis, and the y-intercept is where the function hits the y-axis. So this is a perfect time to set a custom viewing window, because obviously the standard viewing window is not working for us. We go into Window, and you can see here's the standard window settings. Remember, x goes from -10 to 10 and increments of 1. Y goes from -10 to 10 with increments of 1. Alright? So let's go ahead and change the x maximum value to 20. So if we go back, here's 10, so maybe bringing it out to 20 would enable us to see the x-intercept. So let's try that. Let's go to Window, and x max we want 20. So let's type in the 2 and 0, and then we're going to hit graph. And that worked for us. So here's the x-intercept right there. So it looks like we need to go a little bit higher on the y-axis. So let's go back into Window. And so the y max setting, let's set that to 20 as well. So let's move down to the y max, and let's change that to a 20. And let's go ahead and hit graph. Now that's a good window that we have right here for the linear function. We can see the y-intercept and we can see the x-intercept. Notice here you can see the increments. Now the increments here are spaced 1 apart, and the increments here are spaced 1 apart. So let's say that we want to change the spacing a little bit. Let's go back to Window, and let's say we want the increments to be spaced 2 units apart. So let's move that on the x scale. That's what changes it, and say 2 there. And let's go down to the y scale and change that to a 2. So each increment on the x and y axis is going to be spaced 2 units apart. Let's hit graph, and there we have it. They're not as scrunched up as they were on the previous screen. Okay, so if you look to the right, you can see the previous screens that we just had up and how they actually changed from the original one, just by going into the window mode and changing some of the settings. Alright, now let's go to example number 2. First, let's clear out the function. So we go to the y equal button, and then we'll hit clear. Now I'm purposely not going to go back to the zoom mode and change it to the standard window. And the reason why I'm not going to do that is because sometimes you forget to put it back in the standard viewing window, and let's just see what happens. Sometimes you may not need to go back to the standard viewing window. So let's get out of this second function and quit. So we're going to input the function y equals the quantity x plus 9 cubed, subtract 8. So that's the quantity x plus 9, close it, raised to the third power, and then subtract 8. So this is a cubic function, and you should know what the general graph of a cubic function looks like. Alright, so let's just go ahead and hit graph here. Alright, so remember that we're not in the standard viewing window, and we really can't get a good idea of what this graph looks like. So we see a lot of the upper half of the graph, but the lower half we really can't see. It gets cut off. So what's appropriate to do at this point is go back into the zoom and then just hit number 6, get it back to the standard viewing window. So let's hit number 6 and see if that helps us. Well, it looks a little bit different, okay, but still we don't see the lower half of this function. You should know that it keeps going on this way, and it would be nice to see that. So we're going to go ahead and customize this viewing window. We see a lot of the upper half here, so let's go ahead and change the y min value. Let's go down a little bit further. So let's go to Window, and let's go to y min, and let's change that to, let's say, -20. So 2, and there's the -20. So let's go ahead and hit graph. Okay, well, that didn't really help us too much. The y values went down a little bit further here, but we still can't see it. So what that means is we need to go a little bit further to the left. So if we go back to Window, let's go to the x min, and let's change that to -15 and see if that helps. So replace that with a 5, and then we hit graph. So that helped a little bit. Just going 5 more units to the left helped. So here's our cubic function. That's a good view of this function right here. Now the only thing that we could change, these increments are a little bit cramped together, so let's just change that. So let's go to Window, and let's change the y scale, let's say to 3, and let's hit graph. Okay, so they're spaced apart a little bit further than before. It looks a little bit nicer. To the right, you can now see the previous windows, starting from the first window where we graphed the function in standard mode. So let's go one step further with this function, and let's say that you wanted to see what's happening to the function as it goes higher and higher, or if it goes lower and lower. Okay, so what we need to do is we need to change the y max and y min. Let's go into Window, and you can see the y min, we're starting at -20 and we're moving all the way up to 10. But we would like to go from -100 to 100. So let's move this down. So we want -100, and then we want to go to 100. So let's add another 0 in there. Okay, so we're going from -100 to 100. Now let's graph that. Okay, and notice that you can't even see any of the increments on the y-axis, and that's because, remember, we set the scale to be only 2 units apart. So let's go back into the window, and let's set the scale to 5 and see what happens. So let's graph that after we hit 5. And you can see the increments a little bit better here. So let's go back to Window and increase it to 10. Now it's always a good idea for a rule of thumb. if you're going from negative 100 to 100, you're basically going a range on the y-axis of 200. It is convenient to set the scale to a value that divides evenly into the difference of these two numbers. So if you go from minus 100 to 100, you're spaced 200 units apart. So what number will divide into 200? Well, 5 will, 10 will, and so on. So let's go ahead and put in 10. Okay, and let's graph that. Okay, so you can see the increments are spaced apart a little bit more. And then if we went back into the window again, let's go ahead and put in 20 and then graph that, and you can see they're spaced a little bit further apart. So basically what's happening to this cubic function, it just keeps on going up and up and up. Y gets larger and larger, and it keeps going further and further down. Y is decreasing. Now let's go back into window, and there's something that we haven't talked about, and that's this setting right here where it says xres equals to 1. Well, what does that mean? Well, it means that functions are evaluated and graphed at 1 pixel. Okay, that means at 1 pixel. For xres equals 2, functions are evaluated and graphed every 2 pixels. For xres equals 3, the functions are evaluated and graphed every 3 pixels, and so on. So if this said xres equal 8, that means that the functions are evaluated and graphed every 8 pixels. Now, the smaller the number, the better the resolution will be. Okay? But the calculator will graph the function a little bit slower. So the higher the number is, the lower the resolution, but the calculator will graph the function a little bit faster. Now, from experience, the difference between, let's say, xres equal 1 and xres equal 5, there's really not much difference in the speed. Okay? So it's always best to graph the function in the highest resolution as possible. So always keep this setting to xres equals 1. Okay? So this concludes the video on adjusting the graphing window.